Welcome to the deep dive. Ever thought about how we figure out the exact best time to pick crops, to get the most food?
Yeah, it's a really important question. Today we're looking into something interesting, the link between, well, differentiation, that math concept, and making sure we harvest crops optimally for food security.
Right. The sources we looked at really highlight how math isn't just theory. It's practical.
Definitely. It can be a key tool for challenges like figuring out harvest time.
So our mission today is basically to unpack how differentiation helps find that sweet spot for harvesting maximum yield.
Exactly. Let's get into it.
Okay, so differentiation, in simple terms, it's about tracking change, isn't it?
Precisely.
Like think about driving a car. Your speed isn't constant. You speed up, you slow down. Differentiation helps measure that exact speed, that rate of change at any single moment.
That's a perfect way to put it. And that concept of changing rates, it's absolutely vital for crop yields. Crops don't just grow steadily, right?
No, definitely not.
A young plant might shoot up fast, but then, the growth can slow down. It matures.
And if you wait too long?
Exactly. Wait too long and it might start to spoil, or the quality drops. The yield actually decreases.
Okay, so how does the math, the differentiation part, actually model this?
Well, imagine you could graph the yield of a crop over time, like during the harvest window.
You'd see a curve, probably going up.
Right, going up as yield increases and then maybe leveling off or even dipping down if things start to rot or wither.
Okay, I can picture that.
Now, differentiation gives us something called the derivative.
Yeah.
And this derivative, it's like a speedometer for that yield curve.
A scudometer, okay.
Yeah, it tells you exactly how fast the yield is increasing or decreasing at any specific point in time.
So is it growing quickly? Slowly? Has it peaked?
That's what the derivative shows you, the rate of change.
Ah, okay. And this is where it gets really useful for harvesting, right?
This is the key part.
The ideal time to harvest to get the absolute most yield is usually right around when that rate of change, the derivative.
Hits zero. Or perhaps is at its maximum positive value just before it starts to decline.
It's like being at the very top of a hill on a graph, the highest point.
Exactly that, the peak yield point. Or just before any potential decline starts setting in.
So using differentiation helps farmers move beyond just, like, guesswork or tradition.
It gives them a powerful analytical tool. They can look at models based on growth data and use the math to pinpoint a much more optimal harvest window.
Which means more food.
More food, less waste. It directly contributes to, better food security. It's about efficiency.
Now, obviously, real-world farming has tons of variables. Weather, pests, soil.
Oh, absolutely. These models are often simplifications.
But the principle still holds, right?
Right.
Using mathematical tools like differentiation to understand and optimize biological systems.
For sure. That underlying principle is incredibly important in agricultural science, in research, in planning, lots of areas.
It's pretty amazing how a concept from math class finds such a critical real-world application.
It really is, and it makes you think, doesn't it?
About what?
Well, here's something for you, the listener, to chew on. We've seen how differentiation helps with crops. But where else could mathematical thinking like this make a difference?
Oh, interesting. Like resource management?
Maybe. Or environmental conservation, even just optimizing things in our own lives.
Yeah, finding the peak efficiency in other areas.
The potential is huge. It really shows the power of applying these analytical frameworks to all sorts of challenges.
A lot to think about there. Thanks for breaking that down.
My pleasure. It's fascinating stuff.